Good morning, ladies and gentlemen. This is Bele Shenoy, the managing editor of MycoAsia. Thank you, Vijaya, for accepting to do this online training for our friends in mycology and allied fields. Um, for the benefit of the today's audience, I'm going to give a brief introduction of Dr. Vijaya Brahma. Um, Actually, Vijay Brahma, he did a PhD from CSR Institute of Microbial Technology, Chandigarh, where I spent 5 years during 2008 to 2013. Her PhD was on, soil metagenomics, and after her PhD, she moved to Canada and she started doing a postdoctoral work at the University of Toronto on a hospital research project on lung microbiome. Then she joined the SCIC JNU Jawaharlal Nehru University as a UGC postdoctoral fellow in plant transcriptomics. Dr. Vijaya has worked as a research associate at Gati, a DST project of Government of India under the Kiran division. And also she also worked as a mentor with the NGO Vignan Shala International. Dr. Vijaya also steered and transitioned into project management with the Atolos Social Enterprise Canada, Freedom Employability Academy, and recently Ubuntu. Dr. Vijaya Brahma is a member of the American and Canadian Society of Microbiology, and she specializes in bioinformatics, data analysis, science communication, statistics, project management, and programming skills. Dr. Brahma Vijaya has published 15 international peer-reviewed publications, and she holds a US patent to her credit. With this kind of formal words, I welcome you to the today's online training program, Dr. Vijaya. I hope we will have a good time. Thank you so much. Over to you.
Okay, thank you for this lovely introduction, and thank you for having me and giving me this opportunity to present here. So as you know that I have also transitioned into project management lately, but it's great to come back and present the skills I have developed over the years of PhD and my postdoc and presenting it to you. And I was also thinking that we can do a bit of hands-on. So if you are close to your laptop or a desktop, that would be wonderful, because then we can install and do a little bit of easy bioinformatics scripting things. And without further ado, let's start. We'll start with the basic introduction. What I'm going to take you through today is some basic programming in bioinformatics. So just to let you know that what we are going to do is only touching the tip of the iceberg, because it will be just giving you a feel of it. And we can always, if Dr. Shina allows in future, also have much more deeper work on it. But right now, for today's session, I have broken down it into 3 parts. The first is what is the choice of operating system that we use for bioinformatics. So probably I can help you install that, and you can continue learning there, because there are a lot of resources available online to do that. And then we will do a little bit of simple command-based bioinformatics in the shell script. So Unix-based scripting will do. I'll give you certain exercises we can do right now while the session is going on, and you can help me ask questions. And if I'll try my best to answer, and if not, we'll solve it together. And after that, we will also take it forward with some regular expressions, which are much more detailed form of scripting, but pretty easy. And trust me, if I can do it, you guys can also do it. So to start with the first part of the thing, we will start with operating system. So we all have computer, we all have desktops, we all have mobile phones, and all of these systems have an operating system. So an operating system is a program that is being initially loaded into the computer by a boot program. So whenever you start any device, the first thing that you have an interface with is the operating system which loads the application programs. So if you see this in the right panel, if you can see my cursor, you will see that we have different applications like the Word, Gmails, and different applications which are on the top of the layer of the operating systems. So here there are 3 different operating systems which I can show you here. Windows is the most common operating system. Everyone has it. Whenever everyone buys a laptop, they have this operating system. But a lot of bioinformatics happens at the Linux. So we'll be talking more on that. In the right image, you will see that I have made a donut image where I'm talking about different functions of operating system, just to let you know that how important the operating system is. So let's go a little bit deeper into what operating system. So if you see the pink layer, that's the applications. So when I told you applications, they are like Gmails and Word, Microsoft PowerPoint, and all these applications are there. The layer just inside of it's the operating system's outer layer, which is known as the shell. So this is known as a command line interface, which helps us to talk with the applications as a user. So it is the outermost layer of the operating system which manages the interaction between the user and the inner layer, which is the kernel. The interaction between the user is the person who is talking to the computer through the shell. And the innermost layer, obviously, is the core component of the operating system. And here, there's more intense low-level programming is happening. And RAM, CPU, and all kind of things are happening here, the memory and those. So what we call it is a shell script, is somewhere around the middle layer of it. So now we talked about the operating system. And now we are talking about my favorite operating system, and I think the favorite operating system for a lot of bioinformaticians, it's the Linux operating system. Being a command line interface, it's quite powerful. And as you know that if all of you are biologists, and I'm hoping that you all are biologists, so you know that we have big data, huge amount of data to handle. So these kind of data are quite easy to handle in Linux compared to Windows. So if you see some of the valid reasons why I vouch for the Linux system, you will see that there's an ease of usage and availability of efficient data analysis tools. So a lot of analysis tools are being developed on the Linux operating system. So it's quite compatible. And once you get a hang of it, it's much more easier to tweak around and play around with your data. The second biggest advantage is the free operating system. So unlike Windows, where many of people use a pirated version just to get the free version of it, with Linux, you are like ethically clean because it's an open source operating system, and thousands of programs are free, which you can always download. The third is that your productivity will not be compromised. So in the language of computers, we say that it's computationally inexpensive. When I say inexpensive, it's not on terms of money, but it's in terms of the resources, the RAM and things like those, which are being used while running the program. And with Linux, it's much more sturdier and more robust. So with Linux system, it's much more robust. And with bioinformatics, you would need that kind of a system. You don't need antivirus protection. Because a lot of viruses are being designed for Windows. So, with Linux, we are pretty clean and you don't have that hassle of antivirus as well. And with Ubuntu as a Linux operating system, community word has to come because there's a robust community out there for troubleshooting. Even if you're a new novice who is starting to learn the operating system, there's immense amount of support from the community. In the right panel, I have shown you a picture of different flavors, if I may call it, of Linux. So there is Fedora, there's Red Hat, Ubuntu is pretty common, there's Debian, there's different names for it. And the only difference is that being a developer, you can customize your operating system with the requirements. So that's the power of the Linux operating system, that you can do a lot of development here as per the need of your profile or the profession you are into. So these are used in a lot of big companies, IBMs and all, based on, and the best also is that a remote access. So you know that a lot of data is quite heavy to be handled, like omics data, which are pretty big, and you have to do something comparative, then you have to download multiple sequences. So which your simple desktop or laptop, no matter how many processors you have, will not be sufficient. So the remote access and those kind of things can be easily done with a Linux system. So of course, their Mac users can also do a lot of bioinformatics, and in international places, Mac is also used because it's pretty similar, the Linux system, and the command lines work pretty same. So the language is same, and it's much more easier to do that. So far so good. I would want a thumbs up if you are clear with this. And now with the next step would be how to, if you have a Windows system, then how do you install a Linux onto your system? So I have put forth two methods in the left and the right. And if you see the left, it's called the dual boot. Dual boot is a very traditional way of doing, where you partition your Windows system and allocate certain amount of space, and then you install your Linux into it. Being Linux, being open source, you have those, it can be easily downloaded from one of the mirror sites, and then you can take it and download it. How much space has to be allocated is also available, and there are different sites. I can also provide you the resource that how much space has to be allocated for doing simple bioinformatics when you do a dual boot installation of a Linux system. The right, I have also introduced you another method, which is called the virtual box. So virtual box, unlike the method one, where you have to like reboot it every time to move from Windows to Linux, Linux to Windows, in the virtual box, you already have one operating system, Windows, and within that, you have this virtual box, which is a tiny installation application. And inside that application, you can install whatever operating system you want. So inside the virtual box, you can install Linux. The advantage here is that sometimes some application or some analysis you're doing has certain Windows application going on, but you want to also do certain Linux related work. So you can always initiate the program through VirtualBox and do it parallelly. So that is also possible. So today, what I'm going to make you do is the third method, which is Cygwin. A Cygwin is a Unix-like environment, and you can easily install it on a command line interface in the Microsoft Windows. So it's a program which can be used, easily installed, and once you install it, you have a similar interface to install to do your basic Linux based programming. So if you are in front of the computer, then feel free to browse to Cygwin, and then you can install it right now. And then we can move ahead with doing simple programming if you wish. So here's a link to install it. Do it right now.
Sorry, Vijaya, can I ask you a question?
Sure.
I'm Davide Barbagallo from Italy, and I'm a biologist and a professor at University of Catania. Just a question about the how much heavy is to create this partition in Windows system, and if this can affect the normal functioning of Windows. Thanks.
No, usually it does not. It does not affect the Windows at all. There's certain space allocation, and depends on how much RAM space you have. It is possible. I don't have the right numbers right now, but I can definitely let you know the resources where you can do the partition.
Okay, thank you very much.
Thank you, David. So if you have found the link, just on the top of it, you will see the run setup. So if you are in the 64-bit configuration, you have to click the exe file. And then there will be a download file there. it will say that, do you want to allow the app for an unknown publisher to make a change in your device? And you can click yes, this is reliable link, so you can go ahead. And then there'll be a setup program, which you have to install. So click on putting next. So we are installing from the internet. And where will be the space? Where are you planning to install? So that will be the next root installation directory that will be asked. There's a recommended space which is given. So where is the local package directory? So you can do next. And then the package will start downloading. Once you reach the mirror site, there'll be a list of places where the mirror is like from which source you want to download. So I would recommend the location which is closer geographically to your country. Like we are right now in India, so a Singapore mirror would be closer, or somewhere. So you can see from the names, list of names, you will see the extension SG, which would be like for Singapore or the institutes. Otherwise, it doesn't matter. You can always download. So you'll see the extension of the country, like DE for Germany, IL for Italy. And in the third last, I think fourth last is National University of Singapore's link, SG, which you can use. And then select that and press next. So based on the speed of your internet, it will start downloading the package. While it's going on, let me see if we have any old questions. No, somebody asked that would it cause any harm to the PC? No, absolutely not. But of course, I'm not a technical guy. You can always talk to a technical guy, because I have done the reboots and it has never caused problem to me. So while it's installing, if I would like to know if somebody could unmute and let me know if they have done basic little bit of bioinformatics on what kind of problems you are doing, and we'll get to know each other better. Are you using terminal for doing some basic bioinformatic analysis or not? You can use the raise hand option and then go ahead. So Jamuna Devi has raised hand. Can you speak, Jamuna? So if it is installed, the package is installed, you can press the next button.
Actually, I had a doubt regarding
Yes,
the
Nikhil.
installation.
Yes.
So could you please repeat me, like there are available download sites, and which do I select for installation?
So these are called the mirror sites. So mirror sites are the different places from which it's easy to download Sigwin. So geographically, wherever you are, it's always you can find a place which is closer to you. So if you go browse downwards, the fourth last is NUS Singapore, which is geographically closer to India. So I would recommend that use that mirror link to download Sigwin.
All right, ma'am. Thank you.
Yeah. So once you do that, the package will be installing, and we can proceed after that. So no worries. If you still have doubts, we will take it forward from there. I'm still open to questions. I see some raised hands, but nobody's speaking. So feel free to speak.
Hello, ma'am. This is Vruti.
Hi, Vruti.
Yeah, I just wanted to tell that I have used this before, like for NGS analysis. So I was using this KIME pipeline. So
Yes.
in that, we had to do a lot of bioinformatics stuff in Linux.
Huh.
So up to that I have done, and also right now I'm learning about the whole genome sequencing analysis. So all the assemblers and all those stuff.
Lovely.
So yeah, it's a bit too much, but yeah, it is fun to do.
It is fun. It is fun. So if you're doing KIME, that means are you doing some metagenomic analysis?
Yes, it was metagenomic analysis from the scratch. So whatever reads I had got, the raw data, so that I had analyzed from the beginning using the Data 2 plugin. So I was basically generating the ASVs.
Okay.
So I was looking into that, and some part of R programming also I have done, because we had to do a lot of predictive function analysis.
Lovely.
So that is also that, yeah.
So you can appreciate the fact how important Linux is.
Yes, yes, it's very user friendly, and if you know it, it's very helpful.
Hmm.
Yes, yeah.
So
Thank you.
somebody's asking what should I choose for download site while installing Sigwin. So I have sent the download link, and once you reach there, there'll be a mirror site. Go to the fourth last, which is the Sigwin's NUS Singapore, which is very easy to install. Selva Jayanti, does that solve the problem? Okay, so let it download, and I'll proceed a little bit, and then once it's done, you can also try your hands on it. Okay, but I'm here to help, and as we move forward. So once you have a terminal, I'll just share a terminal. This is something like this. Can you see my terminal? Give me a thumbs up if you can see it. Yes.
Yes.
Yeah. So this is a terminal where my installation of it's, if you see the path, it is in the downloads, but I can also use a command of pwd, which means present working directory. So what is my present working directory? So it is telling me the path that where currently I am in the terminal, and this is my path of the present working directory. The next would be, I would want to know that WHO, who am I? That's a legit command. Who am I? So if you put who am I, so it will tell you that in what is the username with which I'm using this terminal. So it has been installed in the FAIN, F-A-I-N, and that's the who am I of it. The next, I would want to know the username. So what is there in what is being, I'm inside uname, which is, okay, I have finished it. So it's Sigwin, which is being installed, and what version of Sigwin that is being installed is also being shown in the terminal. So far, so good. So like that, there are different functionalities of Linux. Oops. So you can see different commands which can be used, like who am I, we have just used. Uname we have used, where if you say uname -a, then you can find out all the information related to the Linux program that you've installed. What is your host? What is your kernel name? Because I said that next to the shell is the kernel, and you would want to know the kernel name. Then you can do -s. So every command is uname -a, uname -n, uname -s, uname -r, like that. That's how you can find out about a bit of information, getting to know about your system. So these are some of the very common Linux commands which are frequently used. And if you get a hang of it, then you can play around with these commands. The manual is pretty robust in using these, and we can take it forward from there. So give me a thumbs up if your this has been installed, and we can do a tiny exercise. Okay. So do you know where it is installed? Do you know your path where you have installed? Most probably it should be in your downloads. So go into the folder. It's an executable file. So double click to it. And it will say that, do you want to allow the app for an unknown publication to change your device? So it's in your desktop. Is it in your desktop? So in this, you have a tiny terminal which can be clicked. And then this is a tiny exercise what we are going to do here. So you have to create a folder, a directory called Kingdom Fungi. Inside the Kingdom Fungi, you will be creating 3 files, which will be 3 different gymnomycota, oomycota, and eumycota. Okay? So let's start doing that. So you open your terminal. You are inside. Just check ls just to see what's inside. So this is my download folder where it is. So there's a lot of mess. So I can just put a clear, clear command to clean the screen. Okay. So once the screen is clean, my purpose is to make a directory. So the command will be mkdir. So if you put mkdir, so that's make directory, and you can name it whatever you want. So mind you, these are case sensitive. So if you are putting in lowercase, every time you have to call it, you have to use the lowercase. And spaces are not allowed, so you can put a hyphen or underscore. Okay. So what I have in my downloads folder is mkdir, a directory which is known as Kingdom Fungi. You can see it if it is created or not by ls and just write K, and if you press tab, so all the K files came Kingdom Fungi, and there is a folder Kingdom Fungi. All good. So if you want to enter the folder now, because we have created a directory or a folder, and inside that we want to create 3 different files. So we will be like cd, which is change directory. From downloads, we are going inside Kingdom Fungi. So I am inside the folder Kingdom Fungi right now. Once we are there, you can create 3 files. And the command for that is touch command, touch. And then you can name it whatever we have, what they were. Gymnomycota. So touch Gymnomycota. And you can do a ls to see the Gymnomycota file is created or not. Yes, you can see inside there is a file called Gymnomycota. Touch Mycota. So you've put a ls now just to see inside the folder. 2 files are made. Gymnomycota space Mycota. That's another file. And the third file which we want to make is, can somebody tell me which was the third file? Mycota. So use the touch command again. So now if I do a ls command, I have created 3 files inside the folder Kingdom Fungi, which are Mycota, Gymnomycota, and Mycota. All good? So that's how I've created 3 files. You can organize it further. And if you want to come out of this file, you know, exit this file, you can go cd space ... Now you are back to the download folder where you have the whole folder of Kingdom Fungi. So are you understanding the hierarchy here? So similarly, you can delve deeper and create more deeper files, like inside Mycota, you can, if you want to go further, you can put different phycomycetes, zygomycetes inside Mycota. You can do further differentiation and things like those. And this is like basically hierarchical filing you can do in the folder. It's similar to Windows where you click the right click and then create certain folders, but I am teaching you the same thing through the command line here. Okay, all good? So if we are all good, then we can move to the next step. Suppose we have to retrieve a sequence. We have a lot of whole genome sequences available, and we would want to take it from a source. So that can be done using wget command or curl commands. So these are 2 different independent commands where you go to the FTP site. If you know the path, you have to find the complete path to download the file, and then where it has to be the destination where it will be saved. So if you see this, wget double dash time stamping means that the whole process will be timed. Then this is the FTP site of NCBI where the genome sequence you want to download's whole path is given. You can always go to the browser and paste it. It has to be a file which is zipped. Usually these are pretty heavy files, so they're zipped or compressed files. And then I have put -p, which means which path I want to download it. So it's -p, and like just now we have created a directory called my fungi kingdom. Just like that, you can give the path where it has to be. It can be a complete path, or if you are in that directory only, then you can define that path here. Similarly, like wget, curl command is there where you can which host you are calling for downloading the sequence, and then you can put the FTP link to it and then download. So mind you, these are right now a compressed file.gz file. Now, when you have a compressed file, you cannot use it as such, and you have to unzip it. So just like in Windows, it's called zip file, right? So in Linux, these are compressed through a gunzip, or they are sometimes also called as gz.z, or there's sometimes tar, which is also a type of a compression where we do. So we have to run a set of commands to uncompress it and open it as such. So right now I have this syntax. So if you have a gz or a zipped file, you use gunzip, which is zipping the gz file, and then you name the file, which has to be unzipped. Similarly, if there's a tar name attached to it, then you can use tar, and then xvf is for extraction of the file, whatever is the name of the file, to uncompress it. So there are different extensions like tgz, tar.gz, tbz, but don't worry about these, because these can be easily uncompressed and the commands are readily available. You can ask, or you can look at the different resources that are available to unzip it. So once you have the sequence, then we can do some little interesting bioinformatics to it. So I'm going to show you a sample sequence which I had recently downloaded. So suppose I have used certain amount of commands, and I want to know what were the last commands that I have used, just to remember that what was the last command I used. So I can use the history command. So it's history, which will give me a history of all the commands that I have used so far. So if you see that we have all the previous commands that we used are in there, and sometimes, so I did some sample run yesterday and I created a new file there. Yes, MycoAsia demo. So there is this file called MycoAsia demo. So I have this file, MycoAsia demo, and in that I have mRNA file. So this was downloaded through NCBI. And if you see it, if I want to see this file, what's inside this file, then I can do is go to the more or less command. Both are good. So you can do more and mRNA-FA, which is a FASTA file. Let me go inside the folder first. I'm still in the downloads, so it's didn't find the command. So I have to go to CD, change the directory to MycoAsia demo file. And inside this file, if I do ls, I have two files. And I'm going to see what's inside my mRNA.fa file. So I'm going to put, I can put less command, less, mRNA, FASTA file, to see what's inside. So you see this is a FASTA file which I have. And if I want to exit this, just Control Z. Similarly, if I want to, you can do the more command as well to see more detail of it. You can do mRNA.FASTA file. And I can go more and more, because this is showing just a 0% of it, and I can go further and see that how long my sequence is. Okay, so I want to exit this out, so Control Z to just be out of this file. So far, so good, right? So let me go back to the sequences. Okay. So now suppose that there is some certain commands which are very, very powerful, which are called as grep commands, global regular expression prints. Suppose you have a particular pattern or particular set of gene sequence that you want to search in the file. How would you do that? So grep commands are very, very powerful commands that can be used for that. And we are going to work with grep commands to see that how you can utilize them. So I'm going to use the grep command here. So I have this FASTA file, right? So if I use, just a moment. grep, global regular expression print. So using this grep command, you have to have a particular pattern. Suppose I want to find this pattern. Okay. I do not know that it's there in my sequence. Or sometimes you have a question you are asking about a particular sequence, whether it's there in your genome or not, particular mRNA sequence or not. So you have that particular sequence, you have that pattern, and you want to test that whether that pattern does exist or not. So we will use the grep command. So suppose it's that T A C C C T G T A G A T C C. Suppose this is a pattern. I want to see is there or not. So I put the grep, double inverted commas, that pattern, and then I'm going to put where I'm searching it, the query sequence, which was mRNA. Fast. So once we do that, I'm going to press enter. So it has given me the output of wherever it has found that pattern in the sequence. So right now it has given me that the particular sequence is occurred 3 times throughout the sequence, right? All good. Okay. Suppose I want to see a particular ID of sequence. Suppose I want to see that whether this ID, which I have downloaded the mRNA FASTA sequence, as this ID or not. I can always do that with the grep command. Suppose I want to find out DM174619. Double inverted commas close. Where am I searching it? mRNA FASTA. And yes, that sequence does exist. So right now, I already have that sequence and I'm just showing you an example, but this can also be done with an unknown sequence and you have particular specific question to ask with that sequence. And grep command is very powerful in doing that. Now, suppose that I have this ID, but I just don't want the ID. I also want the next line where the sequence is there, right? So I want the next 2 lines of the sequence or the next 1 line of the sequence of the given ID as well, because I know this pattern that there's a greater than sign, there's an ID, and then the sequence begins. And I want to retrieve the ID as well as the sequence. How would I do that? So this grep minus space minus A, I want the next 2 lines to it, A2, and then double inverted commas, the ID, whatever the ID I'm looking for, DM174619, double inverted comma close. Where am I searching? mRNA FASTA sequence. And then I'm pressing enter. So now what I'll get is, if that ID exists, then also the next 2 lines subsequent to it. So it's a bit misleading because it's also giving me the next 2 lines, which is the next ID. So let's change the code and do A1, which will be only the next 1 line. So what did I get? I did get the mice ID as well as the sequence corresponding to it. So this is pretty powerful and pretty easy to use if you have the FASTA sequence and you have unzipped it and you want to do it. Now, if I have my sequence and I want to count that pattern, how many times that particular pattern is occurring. So that can also be done. So suppose I want to know this ID grep minus C to have a count of how many times the particular pattern is occurring. So I'll be like grep minus C and then double inverted commas T A A G G T G C A T C T A G T G C A G E T A. So I want to count how many times this pattern is occurring in this sequence. So M is the name of the file where I'm putting it. So according to grep minus C, 5 was the output. That means that I can also count if the particular pattern has been occurring how many times in a particular sequence. Now you might ask that if this is just one sequence and I'm searching, but I want to do it in multiple files, right? So what you can do is, right now I've downloaded only one FASTA file, but what you can do is you can merge the files, so which is used by the concatenate file. Suppose I have this mRNA FASTA sequence. I have another file, which is another FASTA sequence. I have a third file, and now all the 3 files, I want to put it in one file and then run a grep command. Then you can use the cat command. Name the different file names. Like suppose I have mRNA. So suppose I have, right now I don't have it, but I'm just giving you an example. Suppose I have this, sorry. Cat, and I have my file name. And suppose I have another file name. And I have a third file name, which are 3 different independent FASTA sequences where I want to run my grep command. And I'm putting them together with in a merged file. So what will happen now is that I will have all the 3 files put together back to back, and the output will be in the merged file. And now I will run my grep command on the merged file. Of course, the mixing up will not happen because every ID of a FASTA file is unique. You can always go back and revert back and see that in which file or which transcriptome this file exists, or which fungal site, which fungal genome it is, or which bacterial genome it is, like that. So these are the certain files that I have done it. Suppose you also want to find how many IDs are present. So you know that in this grep file, every ID begins with a greater than symbol, right? So I can have a count of it. So can somebody tell me that what would be the command I would be using if I want to count how many sequences are there in this FASTA file? Can somebody write it in the chat, please? Or is it, I have lost you. Grep minus C. Yes, it's grep. It's a lowercase though. It's very, very sensitive. So it will grep minus C. What would be the next step? I know that all IPs begin with a greater than sign, right? So it will be a greater than sign. I'm counting how many sequences are there, and then the file name. And then if I have 1408 sequences in this file. Sounds good? Does it sound like fun? Yes, no, maybe. I'll try it out and see. Feel free to say.
Vijaya, all are unmuted. They can speak up, actually.
Yeah, they can speak up, they can type. I think it's not that difficult. And if you still find it difficult, you can always try it out. So I have given some exercise examples here. You can always try it out, because if you've downloaded the Segwin, you can download a sample FASTA file. Probably already have a FASTA file, because if you all are biologists and have something to play around with. And you can use these set of commands to see that how it goes. The next, if everything is good, so somebody asked me that where do you get the list of such commands? I will also give you the links where you can find these commands. And I think this session is also being recorded. So you can always go back and access this video to go ahead with it. Right, Shantanu? Fine? Okay. So the next command that we will be doing is called the awk command. So awk is also a scanning command, which is also for regular expressions. If you want to search a particular expression and then print it out, then we use the awk command. So let's try awk command this time. So the syntax is that whatever input file you are doing, what you put the command and then see how it goes. So basically awk also scans the file line by line, and then whatever you're looking for, suppose you're looking for a particular field, then you can do it. It works better with a blast file. So right now I'm going to show you a blast file and then show you how it works. Okay. So I'm going to put a ls here because I'm inside the MycoAsia demo file and I have two files here. And this is a sample file for blast that I have taken out. If you want to see what's inside this sample file, what command are you going to put? Put it in the chat, please. So you have to use more or less command to see it. So let's put a less command, and then I'm going to put a sample file. So you see, I have a blast output file. Okay. So this is sequence question query IDs. What was the query's length? The second panel. The third is what was a sequence ID? What was a subject? Sorry, query ID, query length, subject ID, which was the blast result width, subject length. What was the total length? How much was the percentage identity? What is the E value of it? And what's the bit score? The simple blast output that we have got, right? I'm going to come out of it. Suppose I have a blast file, right? And I want to find out that how many of my sequences have 100% identity. Okay, that's the question I'm going to ask. So I know that in this file, for computer, it doesn't make sense. They don't understand blast. They don't understand these things. What they understand is that 100 word or that 100 pattern has to be there in there to look for that file. Okay, so awk command will scan it. So I'm putting awk to search, scan the file and find out. Here the syntax is single inverted comma and then front slash 100. That's the pattern I'm looking for, right? And then I want it to be print. So space, curly brackets, print. Okay, close the curly bracket, single inverted comma, and my file name is sample file blast text. Okay, so what I'm doing is I'm asking through the awk command to scan the file and find the term 100, which is put in front slashes, and print it. And which file am I asking to scan? The sample file blast. Okay, so if I do that, are you ready to see what is going to happen? Okay, so what happened here is that it printed the lines which have 100. Okay, so that means that I can do it with other value or whatever value you're looking for, and then look for which values are you scanning or whatever you're doing. So basically, it depends on what kind of question you are asking when you are doing this. So suppose I want to print, suppose I got this output. So I know that these two IDs have 100% identity, but I have no idea because the top line is lost now, that what line is what. I have no idea what it is. So what I'm going to do is, suppose I want to print the top line as well. So I'll do awk, okay, single inverted comma, curly bracket, print The first line is $1. Okay. That's a syntax. Don't worry about it. If with every command there's a particular syntax, once you start using it, you can always learn about them. So suppose I want to know what was the top line, and I want to print the last line also. So $, and then I want to do the 7th line also. Okay, curly brackets close, single inverted comma close. Where is this command being scanned upon? The file name, sample file blast. Okay, so what will happen now is that it will scan the file. $1 will be the first line. If there is a 7th line, it will print the 7th line and then give it to me as a result. Okay. Okay, sorry. So what is happening here is the first field, not the first line, the first field. So what I'm printing here, if you see the file, less. I told you these work better with the table. So what each field is called $1, $2, $3, $4, $5, $6, $7, $8. So what I'm printing here is the query ID and how much is the percentage identity. So it's printing the first field and the 7th field to let me know that which ID had 100% identity. Okay. So similarly, we can do Control Z to get out of it. Suppose I want to print the first line, which is the first field, and the 2nd field. You can also do that. So this will give me an output of the first field was the hash, and the 2nd field was the query IDs, which are available. Okay. So this is how it is. Suppose I want to know in the 7th field. Okay, the 7th field was the percentage identity, right? I want to only print the sequences which have a percentage identity greater than 98%. Okay, suppose that's the question I'm using. So I know that the 7th field is a percentage identity, and I want to use awk command to scan it and only print the ones which are greater than a particular cutoff, right? So awk, single inverted comma, which field I'm looking for, greater than sign, I want anything beyond 98. Okay. And then I also want to know that what IDs those are. It doesn't make sense otherwise. So I'm going to put a curly bracket and do print $2 to let me know that what were the IDs that will be printed. Okay. And then sample file. So it gave me the ID of those which are beyond 90%. These two IDs were the ones which had an identity of 100%. And I know now that at a particular cutoff, these many sequences, I can do it. Okay. So I'm going back to the questions, and so the slashes are not included in the search. It's part of the syntax actually. So in this command of grep, those slashes are basically the command's syntax, and they are not included in the search. How to uninstall it? I think it's pretty easy to uninstall it as well. I can guide you later on it. Where is FASTA saved for using it in operating system? If it is saved in desktop, and how to open the file in Linux using command. So if you have downloaded your FASTA file, then it should automatically go to your downloads. And in the downloads, you can see the path. Suppose you have to, in your SIGWIN, you have to find out PWD to find out where your path is, PWD, find the present working directory. And there you have to go to the downloads path. This also can be done through, if you open your file on Windows, there will be a right click to find out where the path is, and then you can type it on the Sigwin. So Vedant has a query, and I want to resolve that as well. I think he has downloaded a FASTA file, and he wants to find the path of it. Okay, so let me present the screen. So suppose I have downloaded a sequence. I'm assuming that you're on Chrome, and then you have put the download button. So all the downloads go in this tab, right, where all the downloads are, and it will show you all the recent downloads. Okay, so of course the one which will be the last file would be the one which is on the download, and you can go down to show all downloads to understand where the path is. So I have this file, I have different downloads happening, and I have this file which I have downloaded, which is a yeast genome, reference genome, which I have downloaded. So Vedant, I hope you are there, right? Okay. Give me a thumbs up. So have you reached this much? Have you gone to the downloads and you have gone to the file? You can show it in the folder. Click show in the folder. Okay. So when you see show in the folder, you will see the whole path where it is, right? It's in CD : users, my username. In the downloads, that file exists. Okay. Can you see the path of your file as well? Give me a yes. Yes, Vedant. Okay. So I know this is my path, show in the folder. And this path is also in the top tab where I can just understand this in C : users fain downloads. So let me go to my Sigwin. I'm right now at the same folder. So let me just go completely out to the root. Okay, I'm completely out of here now. Okay, so I have to go to CD, C : because that was a C folder I have. Okay, now I'm inside Sigwin drive C folder. Okay, now I'm going to the username, changing the directory to. Okay, so I'm going to check the path again. It says users and then my username. So I'm going to go to CD. I've already gone to the C drive, right, Vedant? Now I'm going to the next path, which is saying CD, change directory, further deeper into the users. It's case sensitive, so be careful when you're using it. My username. Okay, and then inside that username, it's in the downloads, right? So I'm going to put downloads. Okay, and then I press enter. I'm at the path where my file is. Now I have many downloads right now. Okay, a lot of downloads are here, and I know that my file which I have downloaded have a very special extension. Suppose I have multiple files with that extension name, and it is TGZ because it's a tar GZ file. Okay, so what I can do if I have multiple files, I want to only enlist those files, ls star, which is a wild card, which means that any file got has TGZ can be displayed here. Okay, so it has shown me that inside this C drive username and downloads, there's one file which I have downloaded of Saccharomyces cerevisiae reference genome, and it has an extension TGZ. Okay, and now once I have done that, I told you that these are zipped files. These are right now in a zipped format. So I want to unzip it, right? So because it's a TGZ file, you have to use the tar command. And we have to extract it. So xvz minus command. What I'm extracting, the file name. Capital S. So now I have my file name. I've used the tar command because it's a tarred zipped file with a G, which is gun zipped file. So I have used this command called tar xvzf. My file is extracted. Okay. So if I go here now, I have this different GZ files are inside this tar file. Now you see that this is still zipped as GZ format, right? It's still compressed together, and I want to extract a particular file. In that case, I have to use a command gunzip, which is g unzip, whichever file I'm planning to extract. Suppose I'm planning to unzip this file of reference genome RNA coding, whatever is the coding sequences. I have to know the exact name of the sequence. So I put capital S 288. See, I can press tab. So it'll take me wherever is accurate, and then slash RNA coding. I'm unzipping this GZ file now. Okay. And now I will have this unzipped. Suppose I want to write it to a certain file to make it easier. So what I can do is unzip it, put a greater than sign where I want to write this file. So I have moved this. Wherever this will unzip, please move it to a file name as S we say RNA coding. Okay. So I want that whatever is unzipped, please take it to this file so that it's easier for me to find. Okay. .fb. Okay. It's not a directory. It's a directory right now. This FASTA file, I want to rename as S cerevisiae RNA coding .fa, the FASTA file. And now, if I say ls S cerevisiae .fa, so that file exists now, which is unzipped and in a FASTA format. Let's open it and see it, whether it's successfully unzipped or not. Oh, it's empty. Let's open the previous file to see where it is. S288 and then equality. So there is a FASTA file here, which is all of all non-coding sequences. All good? Now, because it's in my download folder and already a lot of things are already there in my download folder, let me move it to my directory, which was MycoAsia. So I'm going to use a move command, mv, and then move this file to move name of the file, which folder I'm going to move it to, MycoAsia demo. Okay, so that file right now, I've moved to MycoAsia demo. Let me change my directory and go inside that file. Changing directory, ls. So my file is there. All good? Thumbs up? Okay. So where were we? We were doing some regular expressions to see that if we have to find a particular pattern, we use the grep command, we use the awk command. Let us do some more grep commands to understand it or do it better. Suppose I have this file called document.txt. I just created it. It's not a biological sequence. I'll just open it more and show you what it is. I created a random text, which is like Unix is a great OS. Unix is developed by Bell Labs. Learning operating system is fun. Unix or Linux, whichever you choose. Unix is easy to learn. Unix is a multi-user OS. Learn Unix. Unix is powerful. So I have this repetitive pattern where I am seeing that if I need to find out. Now, if you see here, there are some Unix written in lowercase and some Unix written in some capital and some lower cases. Suppose I also have a query, but I am not sure whether inside my sequence, whether it is uppercase or lowercase. But I still need to search that pattern. How would I do that? So very easy way of doing that would be grep command -i. -i means please ignore whatever is the case. Okay. And then put Unix. I want to look for the string Unix, but it doesn't matter whether it's uppercase or lowercase. And where am I looking at? Which is the file name document. Okay. So if I put it, wherever the term Unix has occurred, whether it's uppercase, lowercase, or mixed upper lower cases, it will be generated in the result. So suppose I have to count how many times is the Unix command being done. So you know that we have used the, tell me which command is used, -c. So we can count that Unix grep -c. And if I want to count only this, or if I want to count both, then you can use -i and -c. Unix in the document text. The big is occurred 4 times. So yeah, I hope you're getting a hang of it, getting more comfortable with what I'm talking here. Okay, so let's move to the next command, which is, okay, there's one more grep command, which is very, very useful. And it is, suppose I only want those lines which start with Unix. Okay, although in this case, all I've started with Unix, but suppose there are more lines into it, and I want to pick out only the lines which have the first pattern. Okay, in this case, it's Unix. So what will you do? Grep double inverted comma. This symbol is like the first pattern should be Unix. Close. Where am I looking for? Document file. So it will only give me those files where it is the first starting line is Unix. Okay, that's how it is. Now, let me go back to the slides. We have already done awk command. Awk command is for scanning the file, like we have given this blast results. Okay, and then we have different fields. So the awk command scans it file by file, field by field, that which all sequences are there, and you want to print something which is greater than a something threshold you have to do. For blast searches, awk command is pretty good and a nice way of doing it. It can be more complicated commands, and more complicated combinations can also be done using a pipe command. That means that 2 commands can be combined, separated by a pipe. The pipe command is in your keyboard. I'll show you where it is. It's usually the straight line, which is in front of the front slash. You will see if you put a shift and a straight line, that's a pipe command. Okay, so you can put multiple commands, and if you go to the Linux forums where every bioinformatic problem you have particular, there are a lot of questions and those kind of what code would work for that, because many people have been there, done that, and you can always ask them, or there will be some ready-made codes also available to use these string-based searches like grep and awk. So the third, which I'm going to tell you, is a sed command. So these 3 commands, grep, awk, and sed, are pretty powerful commands and very good commands to search for a particular pattern or string, because in bioinformatics we always have these kind of questions which are being asked. Okay, so sed command is usually used for finding or replacing. So you know this, in the Word you have this Control F to find, and then you can replace a particular string. Suppose there is, let me show you by example. So suppose you have this file, okay? Okay. You have this blast file, okay? Let me show you how it looks like. More. Sample file. So each file is beginning with a hashtag symbol. Suppose I want to change this hashtag symbol to a more different compatible symbol, which my other blast file is, so that I can do some comparison. Okay, so how would I do that? Sed command comes for the rescue. So what you do is sed. I want to replace this hashtag symbol with, suppose, a dollar symbol. Okay, so single inverted comma, substitute front slash hash symbol with dollar symbol. Okay, so what I'm doing here, I've used the sed command. S is for substitution. And what I'm substituting here with hashtag symbol with the dollar symbol. And I want to do it not in one instance, globally, that is throughout the file, not in one file, but throughout everywhere. So what I do is G. Okay, and then I close the single brackets. At which file I'm doing this, that has to be defined. I'm doing it in a sample file. Because I don't want to tweak the original file, I want the result to be written in a new file. So I'm going to name it as new file.txt. Okay. So what I've done here is that I'm using the sed command. I'm substituting the hashtag file with the dollar file globally. That means throughout the file. But I don't want to ruin this file. So what I'm doing it is I have put a direction and putting where it should be written out in. So that is in a new file.txt. Okay, and I'm pressing the end command. The command is executed. Let's go inside the new file to see that what has happened. So I put more new. So you see here, what we have done is we have replaced the hashtag symbol with a dollar symbol. Easy enough? Doable? Okay. I have another file, right? Suppose I have this file called document file, right? And I want to replace Unix with Linux everywhere. So can you tell me how would I put the sed command to replace Unix with Linux? You can put it in the chat and tell me. It's right here. You can use this as a reference. Can somebody try? Is someone typing? Or is it too difficult? Okay, I'll tell you how to do that. So what you do here is, suppose I have to replace Unix with Linux. What will you do? Sed command. Single dollar. Single. Substitute Unix with what I want to replace it with. Linux. Okay. And I want to do it globally, wherever Unix is written globally. And I want to do it, what is a file name? Document file. And then if I don't want to change it, then I put it in a different file. So it's like document 2.txt. Now if I see it, wherever Unix is written, it has been moved to Linux. Okay, so wherever Unix was there, it has moved to Linux because it was case sensitive. So only the small Unix was moved. Okay, that's how it is. So that's how you can substitute a sequence. Suppose you want to replace in the third or the fourth line, that also can be done. Suppose you don't want to replace everything, but only the third line, then you'll be 3S, and then you replace only the third line. Okay? Like that, you can do it. Now, I want to find out, suppose that how can suppose I have this E value, right? I want to see it, a particular pattern. So how can I do it? So what happened? Only the third term, because I only said that the change should only happen in the third line. So that has taken place. Okay. All good? Any questions? Please let me know. If you have any questions, am I audible? Any thumbs up?
Yes, you are audible to me.
Okay. Okay, fine. Now let's move to another command, which is sort command. So suppose you have a set of sequences and you want to sort it alphabetically. Okay, so you have a set of sequences. I want them to be sorted. Okay, you have, suppose, 100 names, and those names are kept randomly, and I want to sort it through Linux command. How can I do it? It's a very straightforward sort command. Let's start with this only. I have this file called newfile.txt. So what I do is sort newfile.txt. So what will happen now? It will I'm moving it and naming it in a place called sort so that it's written in the sort file. Okay, so let's see what happened here. It has been sorted alphabetically, like from lower to bigger, right? You see the difference in the files? It has been sorted right now. What if I want to sort in a reverse order? Then it's sort minus R. And I want to move this file. Okay, file.txt into a reverse sorted. So I'm going to name a new file. And it will be written whatever is in a reverse order sorted. Now, whatever is the list of sequence or whatever is there, I want to sort it in reverse order, and I can open this and show you. It's gone in the reverse order. Okay, so this is a sort command which we can use. Suppose you have two files. Okay, and the next command that I'm going to introduce you is called unique command. Okay, so what will happen is that suppose I have a file which has a repetitive sequences. Okay, something is there which is getting repeated multiple times. But I want to find out that what is unique in that file. Okay, so I can use the unique command to find out that what is there which is unique in that instead of being repeated. I can also count it by using unique minus C. I don't have a file right now which is in a repetitive pattern. I can create one and we can see the unique and we can count it and do some work with that. Okay, let's see. So I have this file. Suppose I can do is I'll concatenate two files. Okay, I'll join this reverse and the sort file and make one file which will have a repeated pattern now. Okay, so I'm putting the file name new file sort, which was sorted in forward order. Cat command is for concatenation. Okay, and the next file new file reverse. Okay, and then I'm putting it as a concatenated file. Concat. What happened is that I have concatenated two files, new file and the reverse file. Of course, it has some repetitions now. You can see it more. It has a file which has a lot of repetitions, right? I want to find out the unique in this command. Unique. And then so what happened here? Okay, I want to find out what particular pattern is unique here. So let's do this. So every file is considered as one time occurring, okay, in this case. But that shouldn't be the case until we have some difference in each of it. So this is the line which was not there. So that is occurred two times. Okay, rest all are occurred at least once. So this is the unique minus D to tell the difference of this. This is the one which is repeated multiple times. Okay. Now, there's also a command known as a word count. This will give us word count of how many, suppose you have a small sequence and you want to know that what is the count of it, how many lines are there. So you can use the WC minus L and the file name to find out that how many lines are present here. So suppose it's WC minus L. There are 10 lines in concatenated file. Okay, so you can count how many lines are there using the WC command. Suppose you have two files and you want to find out the difference between the files as well. Okay, so suppose you have file number 1 and you have file number 2 and you want to find out that what is different between the two files. Suppose, remember we had this hash and this file, hash and dollar file. So you can put a diff command to find out what is different between the old file and the new file. So this command works in finding the difference. There's also a compare command, which is COMP, comp file, where also you can find that file by file, how much is the difference. The only difference between diff command and comp file is that it displays, comp file does not show any prompt message, but diff file does show the difference. So if I have a file called diff, and I want to see the concatenated file and the previous file, which was new file. It told us that there is a difference in first line versus the fifth line. And these are the lines which are different because in concatenated file, they were extra, right? And in the reverse file, these are the ones which are common in both of them. Okay. So these are certain commands, and as I said, I'm just touched the tip of the iceberg, and there are many, many, many more commands. If I show you the list, we have only touched a few, and there are a lot of resources available where we can play around with these files. Once you have downloaded Sigwin, you are quite empowered to play around with these files, and we can do a lot of things with these commands. So feel free to play around. Do not be scared to make mistakes, and take it forward. So I want to end this session by this quote, which says that if there's only number 1.00, 365 days, you are not making any change, then the result will be that you have not made any change. But if you're doing even a subtle change of 0.01, minimum change, even 10 minutes, if you are using it to do a little bit of coding, a little bit of exercise every day, and that's an incremental change. So even if you invest like 10 minutes and do simple basic coding, I will be sharing with you the resources with the kind of links which are available for using different commands and how to practice them. And they're also available in various resources. Then you can go ahead and do it. I'll also share my email address if you want to do some exercise sessions or you have a particular query. So I want to just conclude by saying that Linux is fun. Don't be scared. Command line is a lot of fun. Many bioinformatics tools can be used to command line interfaces. A lot of, in fact, tools are made through a command line interfaces. The shell script empowers us in understanding the parameters. If I give you the example, the blast that you use in the GUI interface or in the browser, you can do a lot more in blast if you know the command line, because in the command line, first of all, you can have a larger query, like the sequence output will be bigger, and many more parameters are there which cannot be put in the browser or in the GUI, which can be done in the command line interface. And of course, if there is any error, it's less error prone, and you would know that where you are making a mistake, that can be tweaked around at the command line, and it's more reproducible. And of course, with remote servers, you can always connect and do a big and larger analysis also. So thank you, Dr. Shenoy, for giving me this opportunity to present. I'm sure I did my bit and I could contribute and help the students in some way. Thank you very much.
Thank you, Vijaya. Thank you very much. Let us have some discussion maybe. If the participants have any more questions, they can ask directly. I think I have unmuted all of you. Yes, you can just directly speak one by one.
If not, then I can also share my email address, or you can direct the questions through Dr. Shenoy, and we can take the questions as well. If you have a particular query while you are practicing it, then we can do it. Okay, thank you, Kalisa.
If there are no questions right now, maybe we can.
Ma'am, I wanted to ask something. So I am actually interested in understanding of pathways and how we can basically I wanted to understand about some biological pathways and do computation analysis on it. So what could be the software that I should be using? So I am actually new in bioinformatics. I am actually from operation research domain. So I just wanted to know how should I start?
So first of all, you should get a feel of what model organism you are, because every model organisms, there's a dedicated website. Like if I say Saccharomyces cerevisiae, it has its own website which has its pathways, but all the pathways are also present in KEGG, which is a Kyoto Encyclopedia of Genes and Genomes. A lot of pathways are present where you can understand which particular pathways you want to understand and learn more about, or simulate it and learn it. There are some very powerful tools known as cytoscapes, which are very interactive pathway maps. That is a total session on its own to learn cytoscape and learn pathway, how to model pathways and things like those. And feel free to resource them and find them and learn yourself. And there are a lot of tutorials also available once you download these platforms like softwares and learn. But as I always say, that start with the basics. Like everything in the back end is the terminal and a Linux coding which is happening. So get comfortable with these simple programs and simple coding languages so that you know how to take it further.
Yeah, Vijaya, I have a question.
Yes.
Okay.
I have 2 sons, so yeah.
Okay, fine. My question is, maybe some of the beginners, might be overwhelmed by the complexities or the apparent complications involved in this kind of bioinformatics application. So, what would be your motivating word for them?
I've already said that it's like you start simple and nothing is difficult. So as I used one of the slides where 10 minutes or 20 minutes of practice also, but be consistent about it. If you want to learn a new language, be it Python, be it Perl, be it R, which is very powerful statistics. If you're a biologist, you cannot do away with computation. Computation will be your asset, but you have to take out time and be consistent about it. And it's possible to learn them. And never be afraid to ask questions. Never be afraid to be vulnerable that somebody might judge you. Feel free to go to any resource. Somebody might be junior to you, yet know better certain things. So go ahead and ask them and learn. And everybody not knows everything. Somebody's immunology is strong, somebody's coding is strong, somebody's mathematics is strong. Go ahead and be not afraid to go to an international author and email as well. So sometimes we as a student get overwhelmed and think that how would they respond? But how would you know unless you try it? So go ahead and do it. And in fact, I have seen more positive responses when you go ahead and email. Like Dr. Shinoy is a wonderful person and you can approach him anytime. And there are many scientists around the world who welcome these kind of queries and they try their best. If not, they can direct you to the right person for more learning. So never be afraid to learn.
Why I asked that question, because when I joined IMTech in 2008, Dr. Raghava, suggested that there are some small programs every biologist could learn and try to implement in their research. Of course, what he meant was like this coding, Unix coding and all. But I am not very much into that. So I would love to learn. Probably this session is a good beginning for me. Second thing is that we had around 130 people. After the break, we have 60 people. So how do you get back those 60 people now?
Can you repeat? Like
No, when we started the session, there were some 120 participants. After the break, some 60 people didn't come back. So how do you get back to those people and convince them this is very interesting, come back to the field?
I think each one on its own. Everybody has certain comfort with different subjects. So whoever wants to learn, they are most welcome. It's more of a pull effect. You have to be motivated to come. I cannot push somebody to do something without their willingness. It's your motivation. Though these 60 people have the willingness to learn bioinformatics, and that's why they are here. So I want to take your feedback. That did you find this basic coding how difficult, or do you think it's doable?
No, but why I'm asking, we understand that this is very important. Looks like the learning curve is very steep, right?
I don't know. It's how you perceive it, I guess.
Okay.
Because when it comes to mathematics, when it comes to computers, people have inbuilt their own mental barrier that whether I will be able to learn or not. But since I that's why I made sure that people download Sequin in their Windows and then try it out, because this is a very basic thing. And some small sequence, if you think that your genome sequence that you have downloaded is too heavy, just take a small chunk of it so that it's manageable, just to play around with those codes. And I will be sharing a lot of links which you can use to practice those codes as well. There are dedicated books also which you can use to do these things.
I remember you were into mentoring. Probably you are still into mentoring. Okay, I think some of these people, out of 60 people who are remaining here, maybe some of them could approach you and just get mentored by you, especially in bioinformatics. So that would be wonderful for them, I guess, including myself.
I'll be happy to do that. And if you allow me, we can delve deeper into more of coding classes in the future as well.
Yeah.
And we can do some tiny coding sessions, 10 minutes, 20 minutes, which will be some basic exercises every day to learn something. And I will be happy to design a module like that.
Oh, great. Thank you very much. Maybe we will have some more questions. Maybe folks, you feel free to ask now, because I'm done with my questions and commentary.
And you can always look back and access this resource because it's recorded now.
Yeah,
So,
yeah. Dear participants, any more questions? Or any more comments? Any feedback? Verbal feedback?
did you like it? Something you did not like? Was the pace too fast? Was the pace too slow? So that it will help me improve the future sessions also. So at least maybe you can put a comment on whether what turned you off, or what you think was not possible, or some struggle that you faced right now.
Could you kindly share your email address? Some unknown person is asking that.
Do you want me to? I can do that, or they can approach.
No, please share it in the chat box.
Sure.
Yeah, please. Can you recommend any project-based homework that I can learn and play by using the command? Mr. Wong or Miss Wong.
Yeah, I can. I would be happy to design some small project questions. That's what I said right now, like 10 minutes tiny questions which we can solve together, or will help you do some exercises like the one which I designed with differentiating different fungal phylas. So those kind of things, and then we can do some tweaking around, do some exercises and things like those.
In the next session, can you please teach us about phylogenetic analysis using coding in Linux?
I think Dr. Shina also already has a phylogenetic analysis session.
Yeah, but I don't use Linux. I believe in Windows type of graphical.
So it's graphic user interface, and already a lot of research has been done and invested onto it. Backend coding is only happening. So you sometimes if something is already available, the fruit is there, so you should use the fruit.
Okay, if someone is really keen on doing phylogenetic analysis using coding and all, they can get into Mr. Bayes and POP. These are the two programs which would need like a kind of coding kind of thing. Okay, and I stopped using POP. Mr. Bayes is very much a hot topic actually. Yeah. Brati says coding is actually fun. Okay. Any more comments or any more questions?
I think if there are no comments, we are already one, so we can disperse. And I've already shared the email in one of the chats. You can scroll up and see.
And I have shared the feedback link to feedback form. If participants would like to give us some feedback, we will be happy to receive the feedback and work on certain things to make it more interesting, maybe more impactful in future. I know it's very difficult to learn all these things in 1-2 hours of session. You know, it would take lots of dedication and hard work and kind of passion to do. I guess it's more than the hard work; it's the passion to learn these things. I would like to request Romana to propose the vote of thanks. Just one more minute, Vijaya. Yeah.
Good afternoon, everyone. I would like to thank Vijaya ma'am for presenting such a wonderful session and enlightening us with the basics of bioinformatics, its commands, and its applications in the various fields. Thank you, ma'am. I would also like to thank all the participants for being mutually interactive throughout the session. Lastly, I would like to thank MycoAsia and Shinoy sir for organizing this session. Thank you, sir. Thank you, one and all.
Thank you, Romana. Thank you very much.
Thank you, Dr. Shinoy, for this opportunity. It means a lot to me because, as you know, that I have deviated my career towards project management. And it was a wonderful opportunity to come back to my basics. And I want to emphasize here that, especially for the women in academia who divert to different fields, and some also drop out of science because of different circumstances. And MycoAsia gave an opportunity to one of those women in empowering. So thank you very much, Dr. Shinoy. You have done a very, very noble job in doing that. So thank you very much. And it means a lot. And there are a lot of women scientists out there who have a lot of skills, and they would love to come in this platform and showcase it. So you're empowering them by doing that. So thanks a lot.
I mean, it is our pleasure to have you in the program and listen to you. I mean, you have been an accomplished researcher, and we have learned a lot, and we are willing to learn a lot from you in future too. And the video that we are recording should be very useful to all of us, including myself. I will be going through the video and learning and trying myself all these things. Thank you very much. And ladies and gentlemen, with this, we are going to close today's session. If you are interested in molecular phylogenetic analysis, you can join for tomorrow's international workshop for Holy Cross College, Agartala, Tripura, India. Have a nice Sunday, the remaining part of Sunday. Thank you very much again. Have a good lunch if you are having the lunch time there. Thank you so much.
Thank you so much.
Yeah, bye.
Bye.